So let's just assume that you now measured temperature and salinity structure in the three oceans. Okay, so you went with a marine vessel or you paddled with your grandma. Okay, you took a CTD and you measured temperature and salinity to the seafloor. Okay. In the Atlantic Ocean, called A in this diagram, here is the A. It's the red curve. P is the Pacific Ocean. And I is the Indian Ocean. So now, I just told you what are the specific characteristics. You have a salinity minimum, which gives you the intermediate water. And you can see the salinity minimum here. You can see the smaller, this is a TS diagram, salinity is on the x-axis. Okay, you can see the region which has the lowest salinity. Okay, and this is the intermediate water. And you can see this minimum in all the three oceans. You can also see the salinity maximum at depth here, which is the North Atlantic deep water signature. All right, and you can identify it in all three oceans, but most pronounced, the salinity maximum is most pronounced in the Atlantic Ocean and in the North Atlantic Ocean. This is where this water mass is formed. And then it moves through the oceans, and it can only be it can only become weaker through mixing with ambient water, which is lower in salinity. Okay? So this is the principle of mixing or diffusion, and I will talk about that in one of the following tutorials. Okay. So now you can also follow the pathway of the North Atlantic deep water through the oceans. And this is done on this slide. It's a very, very colorful, looks a little bit busy, this diagram, but let's just go step by step of what's shown here. Okay? So essentially it's a journey through the oceans using temperature and salinity measurements. Okay? And not from the very top of, not from the surface, but say in the lower part of the water. So what's shown here? You start on the left, and you actually start in the Greenland Sea. Okay, this is where the Denmark Strait is, and then you are in the North Atlantic, and you move across the equator to the South Atlantic, and then going along the Southern Ocean, passing the Cape of Good Hope, Tasmania, moving across the equator into the North Pacific. And along the entire pathway, or most of the pathway, you can actually identify the salinity maximum at depth of the North Atlantic deep water. Here you can see here, this is the tongue of water moving. And this is the deep circulation of the deep spreading branch of the. In the top figure, you can see an image of the temperature, okay? And the temperature distribution actually doesn't give you much information because the water essentially spreads between water that is warmer above and colder below. Salinity gives you the clue. Okay? If you look again at the salinity distribution, you can sort of see that towards the equator in the Pacific Ocean, the signature disappears, and there is no direct, you can't see any direct spreading of the maximum, and more the mechanisms are more diffusive. It's a more mixing mechanism that actually ventilate that part of the ocean. And if I just say ventilate, it's actually the association with dissolved oxygen. Ventilation means bringing dissolved oxygen to a certain region. All right?